Let's look at how we can solve this question here, which is on DE, okay, differential equation. So this question was taken from one of the school tutorial. I believe it's Hwa Chong Institution. Okay, so the first thing is to solve this DE here. Now, understand in H2 Math syllabus, if we were to solve a DE without a given substitution, then this definitely has to be a method of separable. Okay, they have to be a separable form, meaning to say we could actually group the y as a function of y, the y terms. It could be a function, a polymer of y, or it could be, as long as it has a y, it could be a constant, contain constant as well. And we could also put, we're going to group the x together. Then what we can do is actually put a dy and dx as such, right? So you can put an integral sign here, okay? But this is generally what method of separable means. It just means that the variables could be separated to a dy, y on one side, and then x dx on the other side. Okay, so this case here, the first thing we should do is to actually try and move this to the other side first. So I'm going to do that. Dy dx will just be 1 minus 2x plus y square minus 2x y square. Okay, then the next thing I want to do is actually going to try and group this up. I'm going to factorize this out. This is like what you learn in secondary school, which is factorization by grouping. So it's 1 minus 2x here. Then this is y square, 1 minus 2x. Okay, so there you go. There you go. That's the whole idea of method of separable. What we want to do next is actually just group this out. I'm going to factorize this out, okay, because life is good. So this will be 1 minus 2x and 1 plus y squared dy dx. Now, this is great. So what we're going to do next is actually just separate them. So the x and dx is one side, and after which the y and dy is on the other side. Okay. Then what we're going to do next is 1 plus y squared dy dx. Then this will just be 1 minus 2x, and then this will be dx over here. Okay, or maybe we should put a dx here. Yeah. Then this dx we just multiply to the other side, right? So we can multiply the other side. What we get is actually just 1 plus y squared. Okay, you can just see it like that. 1 minus 2x dx. Okay, then you just put the integral sign. Great. So this one is from MF27. You get is ln 1 over a. What 1 a is 1, so tangent inverse, right? Tangent inverse y over 1. Okay, then this is x minus 2x squared over 2 plus c. There you go. So this would be it. Do we need to make y the subject? No, you could make the y the subject. So this would be tangent inverse y equals to x minus x squared plus c. So hence y is equals to tangent x minus x squared plus c. Okay, that's it. Then the next part is part B. Let's look at part B. So part B, same thing, is if in H2 Math syllabus, if it's not given the substitution, it's definitely method of separables. So separable variable, right? So you just separate them one side into the other. Then you try to see if you can integrate it, okay? So from here, same thing, we move the y to the other side. So dy dx. Then this is, this is 6y plus 3 minus ln x minus 2y ln x. Okay, so I'm gonna just factorize the ln x out. This ln x here and this ln x here. Okay, then I think I could factorize this 3 out as well. Okay, so this will be dy dx is equals to 3 2y plus 1, then ln x, then this is 2y plus 1 as well. Just nice. So it's always factorization by grouping. Just understand it has to be method of separable. So you just try and separate them. So factorize the 2y plus 1 out. This will be 3 minus ln x. This is dy dx. So what we're going to do is move the x to the other side and x to the other side and the y to the other side. Okay, there you go. So this will be 1 over 2y, move it to the other side, dy dx equals to 3 minus ln x. Then just dx just multiply to the other side. We get 1 over 2y plus 1 dy equals to 3 minus ln x dx. Okay, so that's it. We can do that. Then just integrate. Okay, so integrating this shouldn't be an issue. This is what we learned in secondary school, which is you get ln, right? Ln 2y plus 1 over 2. Then this is 3x minus 1 ln x. This guy, integrating ln x will mean we need to use by parts. Okay, so this case here, the by parts, the u, this is my u, this is my dv dx. So from here, what we'll get is, I'm going to side quest a bit. So u is equals to ln x. Okay, u ln x, then dv dx equals to 1. So du dx equals to 1 over x, and v equals to x. Okay, so we can just integrate ln x like that. So it's uv is half ln 2y plus 1 equals to 3x minus uv x ln x. So u multiply by v here. Okay, then minus u v du dx. There you go. So there you go. Then that's it. Once we're done, then we could just simplify it. So that's the answer. Okay. So if you have any questions or comments, please do let us know, and I'll see you in the next question.